All right, so today, in class we were talking about the chain rule, and I wrote this nasty example on the board and then just kind of gave up because the numbers got too ugly. But I wanted to show you that it can be done if you just keep your head down and factor. So the example that I gave was I had a function that looks like this. I did 2x squared minus 3x to the fourth power. And what I did is I used the binomial theorem or Pascal's triangle to expand it out. And then things got a little bit out of hand. But basically, when you expand all that out, what you end up with is 2x squared to the fourth plus 4 times 2x squared cubed times negative 3x plus 6 times 2x squared squared, negative 3x squared, plus 4 times 2x squared, negative 3x to the third, plus negative 3x to the fourth power. And if you get all of those coefficients, you get 16x to the eighth minus 96x to the seventh plus 216x to the sixth minus 216x to the fifth plus 81x to the fourth. So this is f of x. Then you can take the derivative of that and you get 8 times 16, so you get 128x to the seventh minus 672x to the sixth plus 1296x to the fifth minus 1080x to the fourth plus 324x cubed. Now, we know that the chain rule says that if I take the derivative here, this should end up being the derivative of the outside function. So I should be able to drop the 4 in front and subtract 1 times the derivative of the inside function. And so what I want to show you is I know that I should be able to make this equal 4 times 2x squared minus 3x to the third times 4x minus 3. And this just kind of got nasty in front of class, and I didn't feel like it was really the best use of our time to go through it. But if you're watching this video, you've got time. So the first thing I notice is that there's a 4 in my factorization. The other thing that I notice is that all of my terms here have an x to the third in them. So I'm just going to bring that out, and I'll put it back in. So I can pull out a 4x to the third. So I have 32x to the fourth minus 168x cubed plus 324x squared minus 270x plus 81. The next thing I know is that I'm gonna have a 4x minus 3 in my factorization. So I do a little bit of wishful factorizing here. I say 4x minus 3 times something has to match up with the original expression. Well, 4 times 8 makes 32, and 4x times 8x cubed makes the 32x to the fourth. But then the problem is that that's going to multiply by the negative 3, so that's negative 24. Well, that's okay. I still have to get up to negative 168, so I need another negative 144. So I multiply here by negative 36x squared. Where did I get that? 144 divided by 4 makes 36. So now if you look at what I'm really doing here is I'm saying that these make negative 24 and these make the other negative 144 that I need to match up with negative 168. Okay, but now the problem is that negative 3 times negative 36 makes positive 108. So I need to get to 324. So I subtract and I get that I actually needed to add 54x here because 54 times 4 makes 216 Add that to the 108, you get 324. Oh, but now the 54 multiplies by negative 3 to make negative, what is that, 162, I believe? And what I just hope here is that my last one is 27. And why do I know it's got to be 27? Because I need to have 3 times 27 make 81. Turns out 27 times 4 gives me the 108 that I need to get up to 270. And I just make that a minus there at the very end. All right. Now, the nice thing about this last piece right here is that I'm almost done. This right here is just 2x cubed. This piece right here is 2x squared times negative 3x. That would give me, sorry, the squared should be on the outside. That would give me 12, but I'm multiplying by 3. This would be 3 times 2x times negative 3x squared. And this is negative 3x to the third. Oh, it's just the binomial theorem again, 1, 3, 3, 1. And so I can factor that to be 2x yeah, sorry, I had the extra x's in there. There's no x on this. Let me fix that for you. There's no x here or there because those are just regular numbers. Because the 27 just comes from the 3, so I apologize. I wrote 3x. I should have just been writing regular x in there. So this just becomes 2x minus 3 to the third power. And the last thing I need to do then is just bring this x right back in to both of those terms there. And because they both have the third power, it becomes 4 times 4x minus 3 times 2x squared minus 3x raised to the third power, which is just the chain rule again. So again, this isn't a proof of the chain rule. This isn't even a particularly enlightening example of using the chain rule. But the idea here is that you can always take your equivalent expressions and factor them to match up with each other. So even if you don't use the chain rule to get your answer, you could factor it to make sure that it is equivalent to the answer you would get with the chain rule. And the other point is, I just didn't like how I left it hanging in class, and I wanted to go through and show you that you could get it done.